So welcome everyone to the working group session for um, Karpenter on Thursday, Feb 27th. So first few things that we would want to talk about is we're soon going to have 1.3.x release. The main features to go in there will be a new validation controller that we are planning to add to the EC2 node class. This would do all the it'll try to do most of the authorization related validations beforehand, and the node class would not go ready if any of those validations fail. And I think the most important one is ODCR. So feel free to go and take a look. I think Reed, you have something to add there.
Yeah, I just want to say, the no class validations are going into the AWS provider. And so I think for this meeting, we're focusing more on the core repo for anything within Kubernetes SIGs. So I think that um, the ODCR stuff is still definitely relevant.
Yeah. We don't have Jason in the meeting, I believe, so he would be the best person to talk about ODCR. But yeah, go ahead. Feel free to check what's in there in main right now, and we'll have a release soon. About the patches, Reed, do you want to talk about the patches real quick?
Yeah, so for the patches, there's some, let me pull it up real quick. Okay, so previously in registration on the node claim, there's a taint that is added for these nodes that are starting up that would basically block node claim registration uh, from the AWS provider side and from other cloud providers. For Omni families that are known, this is something that would be added just as part of lifecycle and then removed automatically. It's something that we would merge in for those known Omni families. But in the case of a custom Omni family, uh, it's something that has to be added by customers or people just using Karpenter for registration to proceed. There is a change in behavior where this will no longer block registration of these node claims, and instead this will be emitted as an event to the node claim. And part of this is a chicken and egg problem that can happen when going from pre V1, where this behavior did not exist, to post V1. I think, Arvin, you had talked about it a little bit too, and seeing
Yeah,
this issue.
yeah, it was pretty hard to migrate one thing at a time because the taint is kind of not in the first previous version, and then it is in the new one, and then we can't block everything on the taint. Yeah, so it's great to see that that's being like addressed.
Like I said, we're still emitting an event because I think it's just meant to event to the node claim. Let's see. Yeah. But basically just make it a little bit easier with an audit logs or something to see that there is a potential for this race condition without it, but it should at least make the migration easier.
All right. Thanks, Reed, on that. Moving over to the community questions, we have this pull request that we want to discuss about.
Yeah, this is my item. This is just a sort of a topic on like disruption in general. I know, Reed, we had a Slack thread where we had a conversation about this as well. I just wanted to continue the conversation here. It sounded like in the Slack thread that when we were talking about disruption, there was a suggestion to reorder it. So we're going from smallest to largest, and that seems like an improvement. But it doesn't seem like it would help for this specific case that I opened the pull request for, where like the node is highly utilized, but only with a few pods. That would still end up in the case where those nodes would end up in the beginning of the candidates, because the way the disruption cost works currently in Karpenter, where the disruption cost is basically roughly scaled to the number of pods on a node with some adjustments made for the pod priority.
Yeah, I'm just reading through it again real quick. But yeah, while I'm reading through that, did you have any of the other thoughts or any other thoughts on the thread, what
So
we had talked about, a couple of the other things and changes that we're making to consolidation?
yeah, I did. So I thought the idea to preserve some sort of state or remember something about the previous attempts to do disruption was an interesting idea. I was curious where that state would go that would be safe to store. Like, would you end up making that like some sort of condition on the node claims that you would expire or something like that, so that you don't evaluate them immediately again? Or how were you thinking of managing that? I'm kind of curious.
Yeah, I haven't really thought about any individual node just yet. The first step that I was thinking about is just make it so that some node claim for a node pool is considered at all. So let's not ignore, like if there's some clustering of nodes, for example, that would be like in the 1,000 node range. If it's a huge cluster, it could be 500, whatever. Basically, whenever scheduling is long and challenging, some node pool could not be considered at all. And for that node pool, you could have like 5 nodes sitting at 40%, and within them, they could schedule onto each other just fine. And so for now, I have a PR that's open. It's in a draft because I need to add tests for it. One idea would be that we're adding shuffling of these node pools. And if we ever time out, that we're actually starting with a node pool that has not yet been seen. And that would be something that's stored on the controller, just in memory. And then if it ever crashes, just like start fresh.
Right.
For getting down to an actual node for a node claim, I haven't really thought through that piece just yet. It would be nice though if we had evaluated some node claim and we determined that it wasn't consolidatable and something hasn't changed necessarily about it, that we're able to progress further along in that node pool or in the node claims for that node pool.
Yeah. Sort of the desire driving that interest for us is that we occasionally have users that configure workloads with like topology spread constraints that have hard constraints. And when they deploy their workload, it'll immediately cause a lot of scale up. And Karpenter will try to disrupt these nodes because they're underutilized, but they can't be disrupted because they're required for a hard topology spread. So they look like good candidates, but Karpenter gets confused about them. So if Karpenter was able to like mark or evaluate it in some way that it had already seen these nodes before and move on to better candidates, that would be great. They do fill up eventually over time because of the least allocated, the way the scheduler works. But when they first spin up, they're all underutilized and Karpenter gets confused.
Yes, then they all just get shifted to the front of the window for disruption candidates, and then you have things that are just never disruptible.
Right.
Considered, yeah.
So it would be great if Karpenter had a way to be less greedy about the candidates it was evaluating and move on.
Yeah, I'll definitely think about it a little bit more and then look at this PR and we can keep the conversation going and Carpenter Dev.
Cool. I'll take a look at your PR too. That's interesting.
Yeah, I'll post it in the chat.
All right. Let's see what else do we have. Anybody has any other things that they would want to discuss? Yeah, Garvin.
Yeah, sorry, I came in late, so I was trying to find the ticket that I've been seeing, the subnet one. This guy. Drop in the Zoom chat.
No.
I'm wondering what is our thought currently for this. Because I feel like there seems to be traction, but I'm not 100% sure what we want to move forward. I guess I have no necessary anything around this. I just see it's been moving, but then I think it's stuck right now.
Yeah.
And I think we can't seem to agree on flag or not. So I just want to try to get this and see if we can get a more unified answer from us.
Yeah, I think thanks for bringing this up, Garvin. That was one of the things that I wanted to discuss today. I think we discussed this briefly in one of the earlier meetings. In general, the consensus was that we don't want to move with a flag-based approach because we could do better here instead of just adding a flag that's, not going to be used by a lot of customers and it's going to be hard to maintain. I think, and I'm going to try to prioritize this in the next few weeks, but it seems like a relatively short-term solution here is either we follow a weight-based approach for these subnets, wherein we start off with a default weight for all the subnets, and then with a slightly lower weight for subnets with 0 IPs. So that way, like you prefer subnets which have more IPs, but even if they don't have IPs, you don't discard them completely. You kind of get around to those, or the one that you suggested, maybe just doing a double pass and picking the subnet with 0 IPs in the second pass. But either one of those should help us, avoid this new flag. I think
I'm
you're on
muted,
mute.
sorry. I guess like in a way, I think like the current PR with the avoid MT is not correct because it's purely predicted. Like it's not like the subnet is empty. But if you are working on this, I guess it would be great. I don't know if you already messaged them back saying, hey, I'm going to be working on this and trying to figure out a better solution.
Yeah, I dropped in a message
Okay.
this morning. I've been chatting with the PR author offline as well. I think they tried their best to come up with a better solution, but it seems like they're stuck. So, like so far, we've just been waiting for them to drive to a better solution. But if they've given it all they can, then I can just take it over from here and then try to see if we can come up with a non-flag-based solution that works for everyone.
Okay, that makes sense. Thanks for taking this up.
Alright. Anyone else have any questions?
I have a second question, but I can wait for whoever wants to go first.
Go for it.
Yeah, sorry. I'm also not sending this through on doc. I didn't open the doc earlier. I have this question around the one I sent regarding, I closed it a while back. It's specific to supporting some way of transporting tags and labels from the node pool to the user data when it's custom AMI. So I closed this a while back because I wasn't 100% sure what we want to do here. But I'm bringing this up again because we are running on custom AMI. And right now what happens is that when we use custom AMI on like the AWS provider, you drop labels and tags when you're building the user data, which I guess I understand, but we want to be able to leverage custom AMI and the flexibility of node pools. And currently there isn't really a way to do that. I think this specific issue went a little bit sideways in that I think we're trying to attempt to have it work with, say, EKS bootstrap script in a way that like makes sense. But I think there are two issues that were open previously, hasn't moved much further. So if you scroll to the bottom, Jonathan linked to down down a little bit more. I think near the these two.
Mhm.
And I'm not sure what's happening. I guess maybe there isn't enough like ask for this, but I'm just wondering what are the current thoughts around the support of custom AMIs with relation to like passing Kubernetes configurations? I know that we moved part of the kubelet info to using node class, but I believe nodes, labels, and taints are still on the node pool. Yeah, we don't know. It's okay too. I can follow up, Jonathan or something.
Yeah, this is not something that I have, I know a lot about, unless anyone else on the team want to take that.
I'll take silence. I'll ask Jonathan. No worries. It's all right. No worries. I wasn't sure if anyone was actively looking at this at all, so that's fine. No worries.
Yeah, yeah. I'll still put this in our logs so that we can take a look at it. Okay. Yeah. Anyone else has any other questions?
Yeah, I sent an issue. Wanted to just briefly talk about that. If you want to open that application
Yeah, sure.
in the chat.
Yeah. I hope it's this one, right?
Yeah, yeah. So again, there were a bunch of very similar issues. So I can just start off by summarizing what I understood are the primary pain points. So there are two broad categories of issues here. So one is, and this is basically related to like termination grace period and how the node claims get stuck on nodes with the do not disrupt annotation, or when we kind of think that they're going to violate PDB. The general concern from a lot of users across these issues are that one is it seems to really confuse them as to what or when they should be using TGP. Like I see a lot of customers getting very confused that some of their node claims are stuck and they're not able to terminate. But I think we have done some work on our documentation to make that more clear. The more pressing concern seems to be the fact that while a node claim is stuck, either due to these do not disrupt pods or due to PDBs, um, there are new node claims that are spun up because Karpenter thinks that these pods should go and schedule on them and kind of nominates those new node claims for these pods. But then if you don't have a TGP defined, or if you have a really high termination grace period, then it can take a really long time for these pods to go away. And in the meanwhile, what these customers are complaining about is like Carpenter continuously churns these new node claims, which are, almost completely unutilized, and then they are paying for this. So any questions so far? Does the problem make sense? Okay. So I think the do not disrupt annotation was a little bit simpler. So I put up a PR for that. I don't think there is a point to spinning up new node claims waiting for these pods to get rescheduled, because they're never going to reschedule. If you have a termination grace period defined, then Karpenter is gonna force delete them after that time elapses. If you do not have it defined, then this node claim is gonna stuck, until these pods get to a terminal state. So I don't think there's a point to, continuously spinning up new nodes waiting for these pods. The bigger question here is about other pods, like pods with PDBs, for example, and whether or not we should factor in the TGP when we nominate these pods for a new node. And I just added that comment at the end. I wanted to see if this is something that we've discussed in the past, because it seems like something that a lot of people are happy about.
Can you explain a little bit more? When you say consider the TGP when disrupting a node, you say?
Kind of, yeah. I mean, when we disrupt a node, like let's say the node expires. So Karpenter today, from what I understand based on the conversation here, uh, Karpenter immediately nominates those pods to go on a new node claim. So it's going to provision a new node claim, for example. But let's say even if you have a TGP of 2 days, it will still almost immediately create new node claims for these pods. So until those 2 days elapse, you are basically stuck with these new node claims that obviously can't do anything, but Karpenter will continue to provision them. So if we can factor in the TGP and just, let's say 30 minutes before the TGP ends, we spin up a new node claim, it basically helps these customers avoid paying for that extra node in some sense.
So I
Yeah.
was reading something. Go ahead, Garvin.
Oh, sorry. No, go for it.
I was reading something, but just so I understand, so there's a forceful disruption method, such as expire or expiration. And then between expiration and TGP, we will provision capacity for the expiring nodes. However, due to blocking annotations, the node claim will sit ready for this pod, which will never move until it is forcefully terminated after its TGP.
Correct. Or if you don't have a TGP defined, then it's going to just sit there forever until someone goes and deletes this pod, for example.
I guess so I think you mentioned in the earlier, like you added support for ignoring do not disrupt pods. That was specific to what exactly? Sorry, I'm trying to like remember.
The termination
Yeah, so
period, I believe, is what will ignore these do not disrupt annotations.
Got it. Okay.
yeah, I mean, just to explain this a little more. So the pods with do not disrupt annotation, they can't be evicted, right? So we can't reschedule them on a different node.
Yep.
So I feel like it's almost a bug that we even consider them as reschedulable. So my fix is fairly trivial. We just, exclude that from being considered as reschedulable pods. So this fixes the problem for those pods because we know that,
Yeah.
they're never going to be rescheduled. But for other types of pods, like the ones with, very strict PDB defined, like they can be rescheduled. But I think the question is, when does Karpenter think that they can be rescheduled? Does it factor in the
Oh,
TGP when it waits to spin up a new node? Or like today, it just spins up a new node immediately.
okay. That makes sense. Okay, I see what you mean.
Yeah, do you have did you already cut a PR for the fix? I think I remember seeing that.
Yeah, 1 second, I'm gonna link that. But that's for the do not disrupt annotation though.
I think it's this one, right? Sarah, you
Yeah.
probably linked it here.
Yeah, I just sent it on chat as well.
Because in my mind, regardless of do not disrupt or a pod that may take a long time to delete up to the TGP limit, they are part of the same problem in that you have a maximum time of TGP for it to delete, regardless of do not disrupt or not. When deleting a node that has any pods on it, they can take as long as TGP.
Yeah.
In which case, does it make sense to not replace, like do the calculation to perform a replacement node when you have it in place? Because you have an unknown amount of time before the node gets deleted, in which case you could be spinning up capacity that will not get utilized. Right? Like both
Yep.
problems seems the same in a way. Yeah.
I mean, it is. There are very similar problems, which is kind of why in the issue that I shared, the customer is complaining about both of these problems. I feel like I'm coming from a perspective of how do we fix this. I think the fix for the do not disturb pods are fairly trivial, right? I feel like for the pods with PDB defined, that's where we need a little more thought. I'm not sure we can exclude it because some customers do want us to keep this node around for as long as we satisfy the pod disruption budgets. But then we have customers who want us to just not spin enough capacity. Like I don't think they want us to disrupt these, obviously, but just like their complaint is about that additional capacity that Karpenter is spinning up, which is lying unutilized.
I guess in my mind, it's hard to satisfy the case because you don't actually know how long a pot would take to terminate. Right? Like
If we have a TGP defined, then we know how long it would take for Karpenter to force delete that pod, right?
Yeah,
force,
that'd be
yeah,
the graceful period there
right.
between expiration and TGP.
Right. What I meant is like if there's a TGP, you only attempt to reschedule close to the TGP, right? Like regardless of do not disrupt or not, right? Like you only
Yeah.
consider anything there afterwards. But that
Correct,
would lead
correct.
to situations where pods can get evicted without a node ready to go, which is the graceful replacement that we have, right? That is that an expectation that we have for our users that there's always a replacement ready during eviction for all the consolidation method except for expiration?
I'm
Like
not
are we breaking
100%
some
sure.
contract? Okay.
No, I was just gonna say I don't think Karpenter makes that guarantee today, at least based on what I've seen so far.
Okay.
Yeah, I mean, I will say this, that like in the general idea of forceful interruption, generally it's been a best effort where Carpenter will be able to remove these pods, and then with excess capacity will be spinning up, since the pods are either deleting or going to be pending. So effectively our provisioning will go through and pick them up. I think one of the more, I don't know if we talked to. I'm also driving in, so I may not have heard this part as well. But I think one of the I guess the more annoying thing for some customers would be the fact that if you don't define TGP, Carpenter will still go and do this forceful exploration. And so I think more it all, like the one issue that I have with this is that like if you don't, it kind of violates expiration for some customers, right? Like you're not actually even attempting at that point to expire nodes if customers do not have if they don't have TGP defined, and they're running one of the scenarios of either having a PDB or do not disrupt annotation.
Are we though? I mean, we are not proposing that we change that behavior, right? I think, and I don't see customers complaining about that particular thing either. I think what they're worried about is when this happens, and let's say you're expiring a node, and you know that my TGP is 1 day. Why are you just spinning up a replacement capacity immediately? Why are you not spinning it up close to that end of 1 day period so that I don't end up paying a cost for a node for 1 day?
Yeah, I guess there's maybe these are some customers have been chiming in, but I do remember on some of those issues that there were customers indicating, especially when they're upgrading and they haven't thought through this new mechanism of expiration on 1.0, that they would just see a really large scale up and none of their like either whether it's jobs or pods that were being blocked by for term or disruption were not being able to be shifted over. And so I think generally, I don't know if customers haven't at least I haven't seen any fundamental issue with using termination grace period, although there are definitely some use cases where it may not be preferable for some customers. Um, there's definitely I did see it at least with the, like with the initial upgrade that some customers were seeing that kind of really large scale up and not being able to utilize the excess capacity.
Sorry, large scale without being able to use the capacity. This is because we are spinning up nodes for pods that maybe just stuck terminating forever or taking a long time to terminate. Is that
Yeah. So
okay? Got it.
Yeah. It's effectively when customers are upgrading, they see that they have that the logic of expiration changes. So in previously where we would do a graceful expiration, now we're doing forceful, and so we're going through all of their nodes and forcefully attempting to expire them. During that time, the same effect happens, but in those cases, some customers haven't set TGP, so they just get excess capacity inside of their clusters, and Carpenter is expecting those pods to be moved over, which never
Got
happened.
it.
Right.
Okay, that makes sense.
Sorry, wouldn't some of these pods though that don't have this annotation move over to the new, or I guess
think
not,
so.
not necessarily move
Right.
to the new capacity. They could could they not reschedule to, well, I guess it would be new capacity, right? Because we would block scheduling with a taint on the previous node.
Right.
Yep.
Yeah.
They do.
So
They do. I think
it's a unit with a split,
Yeah.
not great.
But I think it's not just unutilized, it's also underutilized, right? Even if you do that, you still mark these pods to be scheduled on that node. So effectively,
Right.
you're holding up that node to schedule 20 pods, for example, that will not schedule on it anytime soon.
Yep.
I guess, Sarv, can you just explain to me what your main hesitation with including PDBs in this is, or what you see are areas that we need to discuss more?
I mean, I think that's the part that I wasn't fully sure about, if we can just include pods with PDBs as is, because I mean, we do want to know if there is a problem with those pods violating the PDP, right? Not just having PDP defined on that.
It's two parts of it. I think PDP is one thing. The other could be that it simply takes a long time for the pod to terminate. Like he can catch the SIG term and just hold it forever, right? Like in theory, they can do weird things. I think there's still, at least with PDP, in theory, you can figure out like, hey, am I gonna violate PDP while deleting this node? And consider the pod after PDP, but then I don't know if this is like there's a general issue of like you have no idea when pods will terminate. When is it a good time to create a new node for the replacement to land on there without wasting too much money? As a general
It
problem,
is.
right?
Yeah, it totally is. But I think in this particular case, what customers are more frustrated about is when you know, like when they define a TGP, like Carpenter knows the time that it's
Right.
going to force terminate these pods. So they're like, if you know how long it's going to take for you to terminate it, like why not just wait until that time to spin up new nodes?
I think that makes sense. I think there's no issue there. And in the case that a pod terminates earlier than the TGP, Carpenter would also see it and create a new node for it anyway. So I think I don't see a concern around that. I don't know about others.
Yeah, at least for me, this would seem that it could possibly make customers' life a little better. So at least we'll begin the expiration. Um, I guess the one other argument I could have, like, that I do see is that I guess what happens to pods that were evicted when we begin the expiration that do not like that are off of these pods and go into a pending state. If there is an excess capacity within the cluster, then those pods would just be stuck pending, no? Until like the full termination grace period happens and Carpenter spins up a new.
Wouldn't something else, like, wouldn't Carpenter pick up that there's pending pods and spin up new nodes? Because it's not stuck in the same cycle as expiration, right? Like it's trying to satisfy, like Carpenter is now seeing pending pods. I should reschedule, create a new to put them onto versus the expiration flow, which is slightly different, right?
Yeah, I guess then in that case, well, the expiration flow just goes and deletes the node, and so it
Right.
begins the termination process. So it's like we're effectively doing the same thing, but at that point, we kind of end up splitting the capacity, right, into
I think,
one.
sorry, I didn't mean to interrupt you. Go ahead, Emmanuel.
Yeah, no, I was just gonna say we just end up effectively splitting the capacity, so that you have all your pending pods go into one, and then the pods that reach their TGP
Right.
go to another node.
I think that's inevitable. I don't.
Yeah, maybe.
I mean, we are not even splitting capacity here, right? I think the way I'm thinking about this is, so Carpenter has a logic using which it computes which pods should be rescheduled on a different node. So we just hold off from marking these pods as eligible until, let's say, 10 minutes before the TGP ends. So technically, when you're at that point, Carpenter sees that these are pods that it can, reschedule. It can also reschedule them on the same capacity that it has already spun up, or it can also reschedule it on a new capacity. Like, it's no different than new pods coming up at that time, basically. So we are not doing anything if there are, or we are not making any degradation to the process if you have other nodes that can be evicted safely, because they would still get like a new node assigned.
Gotcha. So we're just omitting out these pods and just saying, okay, just do a scheduling simulation on these set of nodes, and then we'll spin up a capacity. On these set of pods, we'll spin up a capacity for those, move those over, and then just wait for the other pods to go, to be expired. Gotcha. Okay.
Correct. Yeah. So basically, like this PR, wherein we blanketly, mark these do not disturb pods as unreschedulable. In case of other pods, we'll basically consider the termination grace period, and then we will mark them as, reschedulable. Let's say like 5 minutes before the termination grace period ends.
Gotcha. Okay. Yeah, that makes sense to me then.
Yeah, I think I'd have to look at it a little bit more because that's just my only hangup is even if it does have a do not disrupt, if it's close to its TGP, it is reschedulable.
The do not disturb ones, they're not evictable though. So that's the thing with do not disturb. Like, Carpenter checks if it can evict these pods, it can't evict these pods. So it just goes ahead and force delete. So in that sense, they're not really reschedulable regardless of TGP. But that's not true for other pods.
Can I ask a dumb question? What's so bad about just straight up not attempting to create a replacement node for any nodes at TGP? Because you have no idea at what time scale a pod, like from 0 to TGP, any pods can terminate at any point during that time. In which case, are you forcing all the pods to wait into that TGP and then reschedule, which I don't think you can do? Or you just say, I'm just going to ignore you completely and let the natural pod terminating become pending, need new node to come to have as that as the method of creating replacement nodes for a terminating node with TGP. Like, it's a simpler flow, but I don't know if there's danger in that. You may get a slower replacement because it requires you to have pending pods before you create a node, but it's a simpler logic because you're like, I don't know what to do because I don't know how long your pod's gonna take to replace. And I'm just gonna create it when I see it. And that may be true for with TGP or not, because even without TGP, you also don't have any idea how long pods can take to come up. So just because a node is terminating with or without TGP, you have no idea how long it's gonna get stuck, how many pods can get stuck for how long until a new node is needed. Unless Karpenter start like keeping track of how long things terminate, which I don't think we want to do.
Sorry, I think maybe I'm a little confused. So when you say Karpenter does not know how long it's gonna take for a pod to terminate, like in case of TGP, it knows, right? Because after that point, it's gonna forcefully delete those pods.
Right. I guess I was asking like we know at TGP only partially because we have no idea during because like you would I guess okay. I forgot that do not disrupt. You don't even send an eviction to the do not disrupt, right?
Yeah.
So ignoring that, every other pod running on a node with TGP, you still get the eviction, right? You only hard kill after, in which case every pod that's not do not disrupt, you have no idea when it'll get fully terminated. Because
Correct.
you only forcefully do it at TGP. So you can get to end of TGP and there's no pods left, or it could be one or two. Like you have no idea in that window. In which case, is there value in attempting to create a replacement with unknown termination time when you already have a mechanism to create pods that are impending, which they'll naturally get to when they get evicted? If that makes sense. And not attempt at all creating a replacement.
So you're saying if like a node expires and is marked for deletion, and if there are some pods which are holding up that node, then why are we even evicting pods that can be successfully evicted? Is that what your question was?
Oh no. It was like, why create a replacement node? As part of because right now when something expires, right? You attempt to create a replacement ahead of it fully terminating. Because you're like, oh, I want something ready for the pods to move to. I'm asking why do that? Because you have no idea how many of the pods will get stuck in terminating and not have a replacement pod to land a replacement node.
I'm guessing if we don't do that, then we are effectively stuck, right? Like if we spin up a new node, then there is a likelihood that pods with these PDBs have that replacement pod running, so they kind of satisfy the PDB requirements. If you don't spin up a node, then those new pods will never schedule, right? So like there will be no way that the PDP will ever be satisfied. At least that's what my understanding was. Like if we evict these pods with PDB, then the cube scheduler is gonna try to create new copies of that pod, and then once they get scheduled, like Karpenter has a chance of evicting this pod successfully because the PDB is getting satisfied by the new pod.
But is that how that? Okay, so like you would violate PDB if you, let's say there's like two pods running the PDB on them, and you can't evict. Let's say you can't evict both because it'll violate PDB, right? Spinning up a new node doesn't mean that these two pods will have signal to create a new pod on the new node because PDB doesn't scale up to satisfy PDB. It's only when you evict one, because you're allowed to evict one, and then it moves over, and then you can evict the other. Like PDB in a steady state wouldn't create a new pod and land a new node because you think it knows that the node is going down. That makes sense.
Okay, I see what you're saying. Maybe I'm confusing this with
No
search.
worries. Maybe we're going too deep into this. We can talk about this
Yeah.
elsewhere, yeah.
Yeah. No, I think this was good discussion. I think then we generally have alignment that at least in the worst case, like we should just factor in TGP. But I'm going to explore this a little more. I mean, maybe there's a simpler solution here, like you're saying, Garvin, wherein we don't even have to worry about these things. Thank you.
Yeah, that was some good discussion. Is there anything else that anyone wants to bring up? Okay, I guess I don't see any raised hands, so that'll be all then. Thank you all for joining.
Thank you.
Thank you.
Everybody.